Hello everyone. In this video, we are going to see the trigonometric identities. The first one which we are going to start is with the even and odd identities. This video would be covering only even and odd identities. So let's have a check how to prove these three identities. So the first one says sine of minus x is equal to minus sine x. The second one, it is cos of minus x is equal to cos x. And the third one, tan of minus x is equal to minus tan x. Let's have a check pertaining to the proof of these. Now, let me draw a unit circle. Let me draw a unit circle. Before that, let me just, mm, okay, done. Now, let me draw my y-axis and followed by x-axis. Okay, done with the drawing thing. And now let me name them center O, and this is gonna be x and x dash. And here we have y and then y dash. Okay. Now suppose I have a point A here, and let me join OA, and I have a point B here, and let me join OB. Okay. And then after that, I will mark an angle theta here. It's a positive theta, which is going in anti-clockwise direction, whereas this is going to be a clockwise direction. It's going to be minus theta here. Okay. Now join AB. Okay, when you join AB, there's an intersection happening here in x-axis. Let's name it as M. We are able to get two right angle triangle here. Okay. So based on that only we would be proving now. So now let's consider we are going to prove sine of minus x is equal to sine x. That's the first proof which we are going to see now. So let's use different colors to prove it. So let's see how to prove this particular identity. Let me consider the triangle, right angle triangle. In triangle OMA, I need to find out sine theta. In that case, it is gonna be AM divided by, that is opposite side, divided by the hypotenuse OA. Since it is a unit circle, my hypotenuse is gonna be equal to 1. OA is equal to 1 because it's a unit circle. Okay, that's it. Done. So what we get? We get sine theta is equal to AM. And we know that AM is gonna be positive, okay, because it is in this direction of my y-axis. It's a point lying here, right? So if I consider this to be x comma y is positive here. Okay, based on that, I would say that AM is positive. Done. Now let me consider the other triangle. In triangle OMB, what we have here is sine of minus theta. In this case, I would be getting MB divided by OA. If this A is x comma y, then here B is gonna be x comma minus y. Okay. Then here, what I would be having here is, again, OB is gonna be equal to 1 since it is a unit circle, and I would be having MB here. MB is not just positive, it's a negative. I can say it as minus MB, and MB and AM both are same. So which are equal. So I can say it as minus AM. Okay. It's just positive. Just a minute. Let me just rewrite it. I did a mistake there. Let me correct that. So here MB is nothing but equal to minus of AM. That is my MB. Now, this is going to be I2 and this one is going to be 1. So, from 1 and 2, I can say that sine of minus theta is equal to minus AM. What is my AM? Is nothing but minus sine theta. So this is the proof of my first identity. Now let's move on with the second one. So in the second one, let me consider the same thing here. Okay. So now I have cos of minus theta is equal to cos theta. Okay. Let's see how. Now considering the same triangle, in triangle OMA, okay. So now here what we have is cos theta is equal to adjacent side, that is OM, divided by OA. Since it is a unit circle, it's going to be equal to OM. Now, in triangle OMB, again, cos of minus theta is equal to same OM is going to act as adjacent side for this also, divided by OB. Again, it is a unit circle. Since OB is equal to 1 and OA is also equal to 1, I'm going to get OM. So now this one is considered to be 1 and this one is considered to be 2. So from 1 and 2, 1 and 2, you are able to find OM is equal to OM. Both the RHS are same. So from that I can say that cos of minus theta is equal to cos theta. Since RHS are equal, my LHS are also gonna be equal. So based on this only we have proved it. Now let's move on with the third proof. That is for tan. So now third one, tan of minus theta is equal to minus tan theta. No need to look at the unit circle now since we have already proved two things we know very well. Tan of minus theta, we know very well that tan is nothing but the ratio of sine and cos. So here I would be having sine of minus theta divided by cos of minus theta. Sine of minus theta, since we proved it, we know that it is minus sine theta. Cos of minus theta is gonna be positive cos theta. So the result what we get is minus tan theta. So this is the third one. Tan of minus theta is equal to minus tan theta. Okay. Guys, we also say that even and odd because we know that whenever the function is getting defined, if I replace x by minus x and the resultant what we get, if it is minus of that particular function, then I would say that it is a odd function. If I replace x by minus x, but I get my resultant as positive of my function, then I would say that it is an even function. So that's the reason whenever we see the sine function, we say that it is an odd function because the resultant is going to be negative of sine x. Whereas whenever I have cos function, cos of negative x, I would say that it is a even function because when I replace x by minus x, I get a positive. That's the thing. And even the tan is going to be an odd function. In the next video, we would be looking at the different identity proof. Thank you, guys.